Okay, so this is the second page or the second day of inverse functions. The back page here, we're talking about graphing inverse functions. Remember that an inverse is basically switching the x and the y. So to fill out these tables, that's really easy. This table represents your original function, and this table represents your inverse. Here are your x's, and here's your y's. So you literally just need to switch them. My x is going to, for the first one, it doesn't really, you can't really tell, but this guy is going to become my x, this guy comes my y. Here, this guy becomes my y, and this guy becomes my x. We're switching them. So when I input 3 and get 9, now I'm going to input 9 and get 3. You can see that we literally just switch all of those x's and y's. Now we're ready to graph this. I would like you to graph this in 2 different colors. I'm going to graph my original in red and my new one in blue. So my original, remember these are just points, so 1, 1, 2, 4, 3, 9. Those are the only ones that are going to fit there. So if I was to graph the point 1, 1, it'd be right there on my graph. 2, 4 would be right here, and then 3, 9 would be right here. So you can kind of see this little exponential graph forming. My inverse then would be, remember it's got to basically reflect over the line y equals x. So we're hoping it's going to reflect over this line. You could just plug in these points. 1, 1, which would be right here, and then 4 over 4 up 2, and then over 9 up 3. And you can see that this blue one does in fact form the reflection of the red one. We're reflecting over the line y equals x. For these last few, these look confusing, but they're actually really simple. It says in the original function, if I plug in 4 and got 16, then in the inverse, if I plug in 16, I must get 4. Remember, this is my input and my output. So then if I'm working with the inverse, if this is my input, then this guy must be my output. We're just switching those. If my input is 3, then my output is 9, then I would switch. This would now be my input, and this would be my output, 3. If my input is 1 and my output is 1, if my input is 1, my output would still be 1. If my input is 36 and my output, so you can think of it as input and output, or you could also think of it as x and y. If my x is 36 and my y is 6, then I'm switching the type of function, so I'm doing opposite. So I'm going to switch x and y. Now it says my x is 6, so my y must be 36. It's really pretty simple there. Doing the same thing on problem number 2. Again, you have your input or your x and your output or your y, and we're going to flip those. My input's now my output. I'll do those all first. And my output was my input. I'm literally just flipping this table around. Now I can go ahead and graph. I'm going to graph the original in red. So remember, these are x, y points. So like -10, 2, -6, 1. So if I went -10 and -2, be right here. -6, -1 would be here. -2, 0. +2, 1. And 6, 2. So it's kind of like that. You can go ahead and draw your line y equals x, where this should be reflecting, and then see if the next table, which I'm going to draw in blue, will fix that. So this is just a point, so it's like -2, -10. So if I were to graph that, I would go left 2 and then down 10, and then -1, -6, and then 0, -2, and then 1, +2, and then +2, +6. And there's my graph. And hopefully the blue and the red look like they reflected each other. If I folded this paper on this line, that would end up over here, this would end up over here. We're in good shape. it asks you, is the new inverse still a function? Is this blue line still a function? Well, I think it is. You could answer either with the graph and say yes, because it does not fail the vertical line test, or you could look here. My input never repeats itself, so therefore there is never an option for a second domain, or for a domain going to two different ranges. So I would say yes, and I would probably just say it doesn't fail the vertical line test, so it's still a function. Make sure you explain that. The next one we're going to go ahead and graph as well. We have just the function. Fill in the table and use the answer to answer the given questions. Graph the original function and its inverse. So if you want to make another table for the inverse, you can, but I think we can do it from just this. Let's graph the original function using red. So I'm at 0, -7. So that would be right here. And then I'm at 1, -4. Right here, and then at 2, -1, and then at 3, +2, and then at 4, +5, and then at 5, +8. Kind of looks like a line, and it has a slope of +3, it looks like. Now, if I want to graph the inverse, I think I can do this by just looking at this table. When I originally graphed the first red problem, I kind of imagined, I mean, you can see it, that all of this column was my x's and all of this column was my y. For example, for the original problem, if I was graphing that point, I would graph the point 5, 8, right? Which means just go +5 in the x direction and then +8 in the y direction. So now we're going to switch it up and we're going to be working with the inverse. So if I were to do that, I'm going to switch the x and the y. So now this column is going to be my x's and this column is going to be my y's. That same point there is now going to be 8, 5. If you want, you can create a whole new table, but I think we can do this just first looking at these lines to tell us how far to go left or right, and then looking at these to see how far to go up or down. So my very first one is going to be -7 in the x direction and then up 0. So that would be right here. Next, I'm going to go -4 in the x direction and up 1. Again, we are doing this because we are switching our x's and y's to create the inverse. Then I'm going to go -1 in the x direction, up 2. Next, +2 in the x direction and up 3. Then +5 in the x direction and up 4. And last, we're going to go +8 in the x direction and up 5. Let me scoot over a little bit more. Over 8, up 5. Right there. If I connect those, there's my graph, and you can see that that is in fact going to cross or reflect over the line y = x. So last but not least, let's fill in these spots. The inverse of -2. Okay, so what this is asking is, here's my original function. Here are my x's, here are my y's. What's the inverse, or in other words, what did I plug into the original to get 2? Remember, what was my input? My output was 2. This is backwards thinking because we're working inverse. I'm not looking for an output here. I already know my output was 2, so what must I have put in? If my output was 2, right here, my input must have been 3. If my output was -4, my input must have been 1. If my output was 8, my input must have been 5. Ooh, I don't have 14 on there. If my output was 14, what was my input? I don't have 14 there. I think I could just continue this graph though. If you really think about it, we have our x's and our y's. We have 0, 1, 2, 3, 4, 5. I think you can see the pattern. We're just going by 1, 6, 7, 8, 9, 10, 11, 12. I'm just kind of extending this table. They told us the first few values, -7, -4, -1, 3 was 2, 4 was 5, 5 was 8. What do you notice is linking all of these? What's our slope? What's our rate of change? Every time we're just adding 3. So if I added 3 to 8, I'd be at 11. If I added 3 to 11, I'd be at 14. If I added 3 to that, I'd be at 17, and then at 20. I could also take away 3, because in this direction we were going positive 3 all this way. I could also minus 3 and get -10 here, which would mean that this would have to be a -1 if I worked up the value, which that will help us solve these last two. If my output was 14, what was my input? Must have been 7. And if my output was -10, my input must have been -1.